The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you. Good luck with today's lesson.
Okay, well, these are actually pretty straightforward. So, a vertical line is the graph of an equation of the form x equals a, and the line passes through the point A0. So a vertical line is just the equation x equals some constant, just some number. And it's always going to pass through the point A0 along the x-axis there. So, just as an example, if I have the equation x equals 3, well, this is going to be the vertical line at x equals 3. So, this is pretty simple to graph. So x, y, I've got 1, 2, 3 right here. So this is the point 3, 0, and it's just a vertical line through that point. So this is the equation x equals 3, like that. So that's just one example. And another example, say I want to graph x equals -2. Well, again, it's just a vertical line, this time at x equals -2. So 1, 2 here. So this is -2, and it's just a vertical line here. Okay, so that's it. So vertical lines are just going to have a simple equation, x equals some number, and then you just put a vertical line along the x-axis, or perpendicular to the x-axis at whatever that number is. And horizontal lines, those are also pretty simple. So a horizontal line this is the graph of the equation y equals b. So for horizontal lines, it's going to be y equals some number, a constant, and then you're just going to draw a horizontal line through the y-axis at whatever that number is. So then the line passes through, it'll be the point 0b, so whatever this number here is. So as an example, if I want to graph, bless you, if I want to graph y equals 2, well, this is just going to be a horizontal line that would be parallel to the x-axis, and it's passing through the y-axis at 0, 2 in this case. So we've got this. So y equals 2, so it's 1, 2 right there. And it's just a horizontal line like this. And this is the equation y equals 2, and it's passing through the point 0, 2. Okay, so if I want to graph y equals negative 3, that's just going to be a horizontal line through y equals negative 3 here. So along the y-axis, 1, 2, 3. So there's negative 3 on the y-axis, and just a horizontal line. And this is the point 0, negative 3. Okay, so that's graphing where you just generate points from the equation you're given, plot those points, then graph the line, and also vertical and horizontal lines, but those are straightforward. Okay. So any questions, any of that? All right. So now, and I just mentioned a moment ago, so we're moving on to section 3. So now what we want to do is graph with intercepts. Okay, so I just mentioned this in the other example. So now we're going to spend a little more time talking about this. So, the points where a line crosses the x-axis and the y-axis are called the intercepts of a line. So if I've got some line here, so here's my xy plane, and let's say I just have a line coming through here like this. Okay, so this and this, these are my intercepts here, and the point where the line crosses the x-axis is the x-intercept. The point where it crosses the y-axis is the y-intercept. So this is the y-intercept, and this is the x-intercept. So again, for the y-intercept, that is where it's on the y-axis, so that's where x is equal to 0. The x-intercept, well, it's on the x-axis here, so it's where y equals 0. So we can use that to, plug x or y into the equation we're given and find the corresponding intercept there. Now in this case, the way I've drawn the line, the x and the y-intercept are two different points. But if I have a line that goes through the origin here, in that case the origin is both the x and the y-intercept here. So what we're going to see is, well, we know any 2 points make a line, but if we have a line that goes through the origin, that's only going to give us 1 point. So what we're going to do is use this finding the intercept method to graph these lines. But the only time we won't be able to do that is when the line passes through the origin there, because if it passes through the origin, then those two intercepts are actually the same point. And we can't graph a line with just 1 point. We need at least two. So in cases like that, you'll have to find another point on the line somehow. And you can just generate a point like we've seen before. Okay. So, but I mean, I'll show some examples here too. But the point is, we just want to recognize what the intercepts are. Okay, so here, so if I got a line like this passing through the origin, well then this point is, it's both the x-intercept and the y-intercept. So in cases where this is, the line passes through the origin, we're only going to get 1 point when we try to use this method here.
How would you figure out what point you're getting?
What do you mean?
Like, you say that you're only going to get 1 point, but how would
Yeah.
you figure that out? Oh, because
These are both the same.
it's just the
yeah.
origin, so that's,
Yeah.
that's the 1 point that you're getting.
Yeah,
That makes sense.
yeah. I mean, if it's anything else,
You can get,
yeah, it's going to be two different points that it's passing through along the x and the y-axis here.
so the origin itself is the 1 point that you're going to get.
Yes,
Okay.
because this is the only case where the x-intercept and the y-intercept are the same point, which is always going to be, when that happens, it's always the origin.
Okay.
So if the line does not pass through the origin, that means you're going to get, the intercepts will be two distinct points in the plane here.
So they are like both 0, 0?
Yeah, that's 0, 0 there, so. So 0, 0. That's just something to keep in the back of your head. Most of the examples here I'm going to give you will, work out the way that I want to demonstrate the ideas here. But anyway, so what we want to do is finding the intercepts, so that those points where the line crosses through the x-axis and the y-axis. If our equation is given to us in standard form, that's usually going to be the preferred method for graphing. Because if we're given it in standard form, finding the x and y intercepts is usually going to be the quickest way to get 2 points for that line. Okay, so let me, well, I'll write the steps down here. All right. What do we do? Okay. So how do we find these? So find the x and y intercepts. Okay, and this is straightforward. So again, just based on, I had this generic picture here. I didn't really have any labels on it, but, well, the x-intercept, that's when y equals 0. So what we'll do is we'll go to our equation, we'll plug in y equals 0, and then solve for x. Okay, and then in the other case, well, the y-intercept, we can see here, that's when x is equal to 0. So we'll go to the equation, plug in x equals 0, and then solve for y. Okay, and that'll get us 2 different points. And any 2 points make a line, so we just use those to graph it. So I'll write that down here. Okay, so we use the equation of the line to find the x-intercept. So what we do for that is we let y equal 0 and then solve for x. Okay, so then this will give us the point, we'll find whatever x is, say 2, and then the y coordinate there is 0. So we set, or we let, y equals 0, and then solve for x. Then to get the y-intercept, you just do the opposite. That's when you set x equal to 0 and solve for y. So then the y-intercept, that is when you let x equal 0 and then solve for y. Okay. And again, I'm just going to make a note here. This will be the preferred method for graphing a line when the equation is in standard form. In other words, when it looks like this, ax plus by is equal to c. Okay, so if you're given the equation when it looks like this, you usually want to go for the intercept method here. So you find the 2 intercepts and then graph the line. Okay, so any questions on that right now? Okay, so this is just another method we use to graph these equations. Okay, and so if the equation is given to you in this standard form here, well, it'll be pretty straightforward to find the intercepts, because what do? To get the x-intercept, I set y equal to 0. Well, for here, when y is 0, this just disappears, and then you can easily solve for x, and then vice versa. Then to get the y-intercept, that's when I set x equal to 0, so that disappears, and then we can easily solve for y. Okay, so we'll do an example to show that. So let's say I want to graph this. So I have 3x minus 6y is equal to 18. And I'm going to find the intercepts here. Okay, so let's use the intercept method. So first, Doesn't matter which one you do first. So let's just find the x-intercept first. Well, that is when we let, what do I set equal to 0? Y. Yep, so I set y equal to 0. And then I'm going to solve for x. So I go back to this equation. That means I have 3x minus 6 times 0 is equal to 18. Well, this is just 0 here, so that means I have 3x is equal to 18, and then divide by 3. So we get x is equal to 6. Bless you. Okay, so we set y equal to 0. We got x equals 6, so this would be the point 6, 0. So this is the ordered pair. X is 6, y is 0. Okay, so that gets us 1 point on the graph. Pretty quick here. I mean, the arithmetic is not too difficult because, you know, one of the terms drops out, so that makes things easier for us. And now we just do the y-intercept, and for that, that's when we set x equal to 0, and then solve for y. So to get the y-intercept, let x equal to 0, and solve for y. So I have 3 times 0 minus 6y is equal to 18. Okay, now this term here drops out. So what I just have is negative 6y is equal to 18. And then just divide by negative 6 here. So we get what? Y is equal to negative 3. So now this gives us the point, well, x is 0 and y is negative 3. So this is the point 0, negative 3. Okay. Now we've got 2 points, and any 2 points make a line. So all we have to do is plot these and then graph the equation. Okay, so any questions here? Okay. Well, let's go ahead and plot this. So we had the points. I'm just going to put them up here. So the x-intercept was 6, 0, and the y-intercept was 0, negative 3. Six, 0. So that's 1, 2, 3, 4, 5, 6. So 6, 0 is right there. And 0, negative 3, that's 1, 2, 3 down here. So here's 6, 0. This is 0, negative 3. And just go ahead and draw the line in. And what was the equation again? So this is the equation 3x minus 6y is equal to 18. And we've got the intercepts labeled here. So for a lot of these problems, they're going to ask you to graph the equation, and they'll want you to label the intercepts too. Okay, so this would be an example of that as well.
Are you referring to the homework or the exam? Or in both?
Well, I mean, the exam's going to be multiple choice, so I'm not going to ask you to graph anything by hand.
Okay.
But you need to be able to recognize that. In the homework, yeah, you'll probably have to do that as well. But on the exam, I basically just want you to be able to recognize these things.
Okay.
And that. Because it's a multiple choice exam for all the exams in this class. So any questions there? Okay. So So why don't you go ahead, take a moment and graph that equation using the intercepts. So find the x and y intercepts and then graph that equation. Okay, so first, what's the x-intercept here? 7, 0, and the y-intercept? 0, 2. Good. So real quick, I'll just go through it. So for the x-intercept, you set y equal to 0. So we have 2x plus 7 times 0 is 14. So that drops out. We have 2x is 14, divide by 2, and we have x is 7. So this is the point 7, 0. That is the x-intercept. The y-intercept is when we set x equal to 0. So we've got 2 times 0 plus 7y is 14. That drops out. So 7y is 14. Divide by 7. So you get y is 2. So that gives us the point 0, 2. Like that. And then, so for the equation, is it going down or is it going up?
It's going down.
We want to vote on it? You should get this. So I'll graph it by hand, but you should get that. So it's going down. So here's 0, 2. There's 7, 0, so it's going like this. So I'll do that just by hand real quick. So, so for the x-intercept, we had 7, 0. The y-intercept is 0, 2. Okay, so here is 7, 0, and there's 0, 2. Like this. So this is 2x plus 7y is 14. Okay. So whenever the equation is given to you like this, and again, that's what we call standard form, usually just getting the x and y intercepts will be the quickest way to graph that equation there. So let's do an example where the line is going to pass through the origin here. And again, we already said when that's the case, the x and the y-intercept is the same point. So if we actually want to graph the equation, we have to get another point somehow, because we need 2 points, and in the case where the x and y-intercept are the same point, well, then that's only 1 point. So let's say I have this. I want to graph, let's say x plus x plus 4y is equal to 0. So I'm going to tell you right now, whenever something is given to you in standard form, like this is, whenever this constant here is 0, that means it passes through the origin. That will always be the case. Because what happens? If I try to find the x-intercept, what do? That's when I set y equal to 0. Well, what do we get for x? 0. What happens when I try to find the y-intercept? And then I set x equal to 0, and we get y equals 0. Okay. So if you try to use the intercept method for an equation like this, you're just going to get both points as 0, 0. Okay. So I'll just kind of run through it real quick. So the x-intercept, we set y equal to 0. So we have x plus 4 times 0. Is 0. So we get x equals 0, which gives us the origin. And if I try to get the y-intercept, well, that's when you set x equal to 0. So I have 0 plus 4y is 0. So 4y is 0. When we divide by 4, we get y equals 0. So again, just the origin. So that means we have to get another point somehow, right? Because if we want to plot this, we need more than just 1 point. So then what you do is you just go back to generated points. So now we only need 1 more because we know this goes through the origin. So we just want to pick some other value of x or y and then solve for the other variable here. So, guess it doesn't really matter, so we now pick another value for some variable. Then solve for the other. So it doesn't really matter what you do. I'm just going to say, let's pick y equals -1. So I'm just going to plug y equals -1 into here, and then I can solve for x. So then I would have x plus 4 times -1 is 0. Well, this is just x minus 4 equals 0. So then I just add 4 to both sides. So I get x is equal to 4. So this gives me the point 4, -1. Yeah.
So you're saying that you can pick any number, like any...
Yeah, just pick one of the variables, pick a number,
Okay.
and then just solve for the other one. So now we've got 2 points, 0, 0, 4, -1. So let's go ahead and plot that.
So we don't do for y?
Sorry?
We don't do for y?
No, because we already have this point, and now we just made a second point. And that's all we need, yeah. So remember, any 2 points make a line. So we've got 2 points. Let's go ahead and plot it. So we had the points 0, 0, and 4, -1. Okay, so it goes through the origin, 0, 0, and then 1, 2, 3, 4, and then down 1. Okay, so then 4 and -1, so we're right there. And then just drawing the line. So this is x plus 4y equals 0, passes through the origin, and goes through this point 4, -1 here that we found. So any questions here? Okay, so that is x and y intercepts. So again, if you're given the equation in standard form, and as long as it doesn't pass through the origin, and again, it will only pass through the origin if this constant over here is 0. If it's anything else, then the x and the y intercept will be 2 distinct points, so then you can use that method to graph it easily. Otherwise, if it's something like this, you'll have to find another point somehow. And it doesn't really matter how you find it, just as long as, you just use the equation to find some other point, like that. Okay, let's take a short break, and we'll come back and start on section 4. So in section 4, we're going to talk about what is called the slope of a line. The slope is basically a measure of how steep the line is. So that's what it is, kind of in plain words. So, okay. So the slope of a line is, we normally call it m. This is basically defined as what we call the rise over the run, or the change in y divided by the change in x. Or a more compact notation, we'll call this delta y over delta x. So this is like the grade here. So this is telling us for if you move some amount in the horizontal direction, that's in the denominator here. Then the numerator is telling you by how much you need to change in the vertical direction.
So, for a slope of, say, m equals 3/2, let's just say I have a grid of values here.
Okay. So what this is telling me is, I always think of, look at the denominator here, it's 2. Now I'm always going to interpret this as positive, so even if, say the slope is a negative number, always consider the denominator positive. So what this is telling me is I'm going to walk 2 units to the right. So let's say I'm here. I walk 2 units to the right, 1, 2. I have to go, according to this, 3 units up. So I go 1, 2, actually up here, so we add another row.
Like this. So let's say I start out here, so I go 1, 2 units right, and then 1, 2, 3 units up, like this. Okay, so I go 2 units, and then 3 units up.
Now if this was negative, so let me do an example
Where the slope is negative here. Okay, so again, let's just say I have some grid. Okay, and let's say my slope m. Let's go -2/3. Okay,
So now, what this is telling me for every 3 units I go to the right, I'm going to interpret this negative fraction as, I'm going to take the numerator to be negative. So since that's the case, as I move to the right, I'm going to go vertically down in this case. Okay? So if the slope is positive, as I move to the right, I go up. When the slope is negative, as I move to the right, I'm going to go down. So for here, -2/3. So I'm going to move 3 units right. So let's say I'm here. So I go 1, 2, 3 units right. And then the -2 in the numerator here tells me to go 2 units down. So I go 1, 2. So if I start here, I go over 3 units. So 1, 2, 3, and then down 2, like this.
so let's say I'm here. I'm going to move 3 units to the right. So 1, 2, 3. And then I'm going to move 2 units down. So 1, 2. So I'm right here. So what this would tell us then is this point and this point. If I have a line that has this slope, basically if this point is on the line, I can kind of walk in the direction the slope is telling me, and I can get another point here. Same here as well. So if this is a point on the line, then I can walk along in the direction the slope tells me, and I can get another point here. Okay, so change in y over change in x, and then we interpret it as I'm always going to walk to the right, and then depending on if the slope is positive or negative, if it's positive, I'll be going up as I walk to the right. If it's negative, I'll be going down as I move to the right. Okay, so since this is a positive slope here, so we move upward as we walk to the right. And here, since we have a negative slope, we will move downward as we walk to the right. Okay. Okay. So, okay, so say we want to calculate the slope of a line. Okay, so that was just kind of how we interpret the slope there. It's just change in y over change in x. So it tells us, you know, as we're walking to the right, how much am I going up or how much am I going down as I'm moving to the right here. But how do we get that number? Where does it come from, and does it show up in our equation here? So we have a formula for calculating this, so I'll just write it down. So the slope of a line that passes through the points, let's say x1, y1, and x2, y2. So these are just two different ordered pairs. Is m. Well, we defined this as change in y over change in x. So that means what it's going to be is it's going to be the difference of these two y coordinates divided by the difference of these two x coordinates, because that's the change there. So y2 minus y1 divided by x2 minus x1. And that will give you the slope for the line. Now this is assuming you're given 2 points. But I mean, you'll see in the homework, they'll give you 2 points on the line and they'll say calculate the slope. So let's do an example there. So let's say we want to find the slope of the line passing through let's say 8, 5, and 6, 3.
No, what I like to do is just label one of the points x1, y1, the other one x2, y2. It doesn't matter which one, just make sure you keep your labeling straight.
So I can just call this one x1, y1. This can be x2, y2. So then the slope, m, is just y2 minus y1. So in this case, that would be 3 minus 5 divided by, and then x2 minus x1 would be 6 minus 8. So 3 minus 5, that's negative 2, and 6 minus 8 is also negative 2. So in this case, the slope is just 1. Or, whenever we're left with an integer like this, a lot of times, sometimes we'll want to write it as, well, in this case, 1 over 1. If it was 3, I might write it as 3 over 1. Or if it was negative 2, I might write it as negative 2 over 1. And that's just to remind me, for every one step I take to the right, I'm taking however many steps up or down in the appropriate direction. So in this case, basically, I move one right, I go one up. One right, one up. One right, one up. In this case. So let's do another one. Okay, so let's go ahead and find the line that passes through these 2 points, negative 3, 4, and 2, negative 1. So again, I'm going to label these. So x1, y1, x2, and y2. Okay, and then m, again, it's the change in y, so y2 minus y1, so that's going to be negative 1 minus 4. Divided by, and then x2 minus x1, that'll be 2 minus negative 3. Okay. We want to be careful. Watch the signs here. That's important. If we make a sign error or something like that, we're going to get the wrong slope. So just be careful with your arithmetic here. Okay, the numerator, so negative 1 minus 4 gives me negative 5. So in the numerator, I've got negative 5. Down here, now minus a negative, that'll be plus. So 2 and 3 gives me 5. So this is negative 5 over 5, or negative 1. Or I could think of it as negative 1 over 1. So now this slope is telling me for every step to the right I take 1 step down as well. Okay. here's one. Go ahead and calculate this slope. Okay, go ahead and calculate that slope. Okay, what's the slope? What is it?
7 over minus 5, negative 5.
Okay, so 7 over negative 5, so just negative 7 over 5, right? Okay. So if this is x1, y1, and that is x2, y2, then the slope m, y2 minus y1, is 4 minus negative 3 over, and then x2 minus x1 is negative 7 minus negative 2. So in the numerator, well, minus the minus is plus, so that'll be positive 7 over. Down here, the minus minus is plus, so negative 7 and positive 2 is negative 5. And I mean, it doesn't matter the minus sign where it goes, so I'm just going to think of it as negative 7 over 5. Because again, I like to interpret the slopes so that I always think of the denominator as positive, so I'm always walking in the positive x direction, so I'm walking right. And then whatever the sign of the numerator is, that tells me if I'm going up or down. If it's positive, we're walking up. If it's negative, we're walking down. So in this case, for every 5 steps I take to the right, I'm taking 7 steps down. Okay, so okay, well, since the slope tells us, where to walk, if we already have one point on the line, then starting at that point, if we kind of walk in the direction the slope tells us, that's going to give us another point on the line, and then we can graph the line here. So think of it as the point you're given, just think of that as like a starting position, and then you're told what direction to walk in. And then as long as you walk correctly, the next position you land in, that's going to be another point on the line there. So I have a point and the slope. I can graph the line. So So if I have a point, you start at the given point, and then using the slope, we walk to another point on the line. So if you're given a point in the slope, graph the point and then walk in the appropriate direction according to the slope. So let's go ahead and graph the line passing through, let's say the point 1, 2 with slope let's say -4/3.
So what I'm going to do is plot this point, and then starting from this point, I'm going to walk in what direction here? How am I going to walk?
Right,
Right 3 and 4 steps down. Starting from here. So this is your starting position. And then this is like your map. It's telling you where you're going to walk next to some other point on the line. Again, as long as you follow this correctly, the point you land on after walking away from here will be another point on the line, and then you can just graph the line.
Okay, so 1, 2. So I'm at 1 and 2. So I'm right here to start. Okay. Now from here, so the point was 1, 2, and the slope was m equals -4/3. Okay, so from here, I'm going to walk 3 to the right. So I go from here, 1, 2, 3, and then I'll go 4 down. So 1, 2, 3, 4. So about here. Okay, so I go 1, 2, 3, and then down 1, 2, 3, and 4, like this. So it's 2, 3, 4, and then it's 1, 0, -1, -2. So this is 1, 2, 3, 4. That's 4, -2. And it's like that.
So you have a point and a slope, you can actually graph the line. Now we don't know what the equation is, but that's something we'll be able to figure out. We're going to be coming to that. Okay, so why don't you try this? So go ahead and graph the line passing through, let's say -2, 3 with slope m equals 1/4.
Okay, so I'm at 1, 2 here. So if I go 3 to the right, I'm at 1, so this is 2, 3, 4. So I'm at x coordinate 4. And then if I go down 4, well, right now I'm at 2, so that's 1, 0, -1, -2 for the y coordinate. Okay, so we're just counting basically.
Is that good? All right, so go ahead and try this one. Okay, so here's our starting position. We're at -2, 3. So from here, where am I heading?
You're going to the right 4 times.
So I go 1, 2, 3, 4, and then what?
Up 1.
Up 1. So right here. So this is what, 2, 4. That's the point 2, 4.
So from here, again, so I'm walking right 4 units. That's the change in x, or the run. And then the change in y, or the rise, is +1. So we go 4 right, 1, 2, 3, 4, and then up 1. So that's the point 2, 4. So we look like this.
Questions there?
Okay. Let's go ahead and write those steps down. In a second. Okay, so graphing a line, with the slope and a given point. Okay, so first, plot the point. and then use the slope formula, m equals rise over run, to identify the rise in the run. And then you start at the given point and count out the rise and the run to mark a second point. And then 4, draw the line.
Okay, so we did a couple examples there. Now, I want to talk about the slope for a couple special cases. So what is the slope going to be for a horizontal or a vertical line? So let's talk about that for a second.
Okay, so slopes for horizontal and vertical lines. Okay, so first, I'm just going to draw some vertical line in here. So remember, a vertical line has the equation, what?
X is 0, and then Y 0.
No, A equals,
Oh,
no.
X equals A.
X equals A, some number. X equals a constant, right? So let's just say 2. So let's say we have the vertical line X equals 2, just as an example. Oh wait, I want to do horizontal for whatever. Doesn't matter. Okay. Anyway, this is fine. Okay. So I have a vertical line here. Well, this is a very steep slope, right? Can't walk up that. Well, notice, so remember, we interpret slope as rise over run, or change in y over change in x. Well, what's our run here, or the change in x?
0.
0, yeah. It doesn't move in the horizontal position. It's this. So the change in x is 0. Well, remember, the run, or the change in x, that is in the what for the fraction, for the slope? Numerator or denominator? Denominator. Remember, we can't divide by 0, right? It doesn't make any sense. So we can kind of also interpret that as it doesn't have a slope, it's not defined. Or you can also think of it as it's an infinite slope, because you can't really climb up it here. So in the case of a vertical line, since the change in x, or the run, is actually 0, the slope is not defined, because we would have to be dividing by 0, and that's not something we can do. So there is no change in x, or I should say, yeah, there is no change in x. Or in other words, the run is 0. But since m is equal to rise over run, we get that m
is a rise over 0, so this is undefined.
So something else we would say is this has no slope. So something to help you remember that. For the word no here, this and this are vertical lines on the end. So vertical lines have no slope. These are vertical lines right here.
So you can think of it as,
No slope means, yep. So vertical lines have no slope, and these are vertical lines you can match it up with. It's the only thing I remember from 8th grade math. That specific detail. I remember all of it. That's the only thing I remember my teacher told me. Anyway. So we have this. So vertical lines have no slope, or it's undefined, and that's because the change in x, or the run, is 0, and that is the denominator for the slope, so it's undefined there. Well, what about horizontal lines?
so for horizontal lines. Okay, well, what's the equation for a horizontal line then? Y is equal to some number, so let's just try something. So let's just say 3. So let's say I've got this equation, y equals 3.
Okay, well now, change in x could be anything, right? So that's fine. What's the change in y, though? Yeah, there is no change in y. Y is fixed. It's not changing at all. Okay, well that means the numerator is 0, but the denominator is not 0. You know, it's something else. Well, that's okay. We can have a 0 in the numerator. There's no trouble there, right? It would just be 0 divided by a number is 0. Yeah. So for horizontal lines, the slope is just 0. It's flat, right? So that's a flat line. It's no, I mean, if you're trying to walk along this line, there's no issue there. You just walk across it. The vertical line, I mean, it would be like trying to climb a sheer, flat surface. This is just, if you're walking down the road here, and it's perfectly flat.
So in this case, there is no change in x. Or I'm sorry, there is no change in y. There is no change in y. In other words, the rise is 0, so m would be 0 divided by the run, which is just 0. Okay. So for vertical lines, there's no slope or an undefined slope. For horizontal lines, it's always just 0 slope. And you can remember this as well. Letter Z for 0 has these horizontal lines here. So we can say 0 slope.
So I guess I remember 2 things from 8th grade. Okay. So vertical and horizontal lines, the vertical lines have no slope or undefined. Horizontal lines have 0 slope, or it's just perfectly flat. Okay.
So slopes for these lines are relatively easy. Just don't get them mixed up. Okay.
Good luck with today's lesson.